Okay, I think I really did enough examples of the basic types of problems in the videos. So in these selected homework problems, I'm just going to do different kinds of looking problems. So we're going to start with 96. Find a general formula for the integral sine of ax, cosine of ax. All right. Sine of ax, cosine of bx. Wait. Nope. Cosine of ax as well. All right, there's a couple of ways of doing this. You might think product to sum is a very natural way of thinking about this because that's the formula that we had for A's and B's. But I don't think you need to use that. And this is weird. This seems just too easy. So let's see if it actually is easy or not. We can just do the U substitution, no? If U is sine of AX, then du is cosine of AX times A dx. So we need an A, but A is a constant. We can introduce A no problem. Now, all of this is just du. Yeah, I thought this was going to be messier. And we get 1 over A times integral of what's left over. Just sine of AX, which is just U. Antiderivative of U is 1/2 U squared. We get 1 over 2A times U squared plus C. Nothing to it. And 95 would be very similar as well, but not quite the same. All right, 112. A lot of times I get surprised and problems are nastier than I thought, but find the area of the region bound by these graphs. So very important that we identify the right area. Sine cubed from 0 to pi over 2. Sine of x, sine cubed, x equals 0, x equals pi over 2. And let's zoom in to make this a little easier to see. All right, so we're looking at the region between these 4 things. What is the region trapped between these 4 things? Okay. And it's going to be this region right here. All right. Actually, these vertical lines are not useful. Not really that useful. And we're finding the area. So the area is just going to be top minus bottom. Integral of top minus bottom. So top is sine. Again, if I zoom out, you can see it. Top is sine, so it'll be the integral of sine minus sine cubed. And then we just have to evaluate the integral using topics of this class. So the antiderivative of sine is no problem. That's negative cosine of x from 0 to pi over 2. But now we have the integral of sine cubed. How did we do sine cubed? There were a couple of different ways. But if we write it as sine squared times sine, we get something with cosines. And then with a sine, which is its derivative. So let's write sine cubed as sine squared. Again, sine cubed is sine squared of x times sine of x, which is 1 minus cosine squared of x times sine of x, which is sine of x minus cosine squared of x sine of x. We'll use this. So, all right, let's really not skip too many steps. We'll just replace the sine cubed with this, and we know the integral of that. So we get this becomes negative cosine of pi over 2 minus cosine of 0 minus the integral from 0 to pi over 2 of sine of x minus cosine squared of x times sine of x. Cosine is the x coordinate on the unit circle. X coordinate here is 0. X coordinate here is 1. It becomes 0 minus 1. like so. And we'll have to split up these two integrals. So we can do a u substitution. Negative times a negative is a positive. And now we can do a u sub on this guy over here. I'm really feeling like I have taken extra steps here that I did not need to take. I think if you, yeah, here it is. I am doing extra steps here. I think my problem solving strategy is fine because you're not always going to know. But if we had just done this at the start, the sine of x's would have canceled. So, right? Because this sine of x is that integral of sine of x. So these two things cancel. So if we saw that at the start, it could have saved some work, but it's fine. You don't have to have precognition. You don't have to be able to see the future. Working a little extra is not the worst thing in the world, depending on other life situations, I guess. If u is cosine of x, right, du will be negative sine of x dx. So just add a negative, and then look, everything underlined in blue is our du. We'll get negative integral of just u squared du. And again, if x is equal to 0, what's u? Cosine of 0, which is 1. If x is pi over 2, what's u? Cosine of pi over 2, which is 0. So we're now integrating from 1 to 0. Negative 1/3 u cubed from 1 to 0. That's negative 1/3. 0 cubed minus 1 cubed, which is just positive 1/3. Let's see if that's our answer. Integral from 0 to pi over 2 of sine of x minus sine of x cubed dx. Whoa, it's 1/3. Look at that. We did it. All right, next problem. (117). Solve the differential equations dy d theta equals sine to the 4th of pi theta. Jason, you haven't talked about differential equations yet. What's going on here? That's why I'm doing this problem here, because I wanted to assign it, but I haven't talked about differential equations yet. A differential equation is just an equation with a derivative. Differential equations are actually very complicated, but in theory, it's just an equation that has a derivative in it. So give me a function. Give me a function y so that the derivative of that function with respect to y, the derivative of that function y with respect to theta is equal to this other function of theta. That's all this is saying. Right? Find a function y. Y is going to be some function of theta with the derivative of y with respect to theta is sine to the 4th of pi theta. That's what this solving a differential equation means here. Now, maybe the differential equation has other derivatives in it or more complicated methods, but here there's actually going to be infinitely many answers. If two things are equal to each other, then their integrals are equal to each other plus or minus a constant. So we can take the antiderivative of both sides. What's the antiderivative of the left-hand side? Well, whatever it is, it should equal the antiderivative of the right-hand side with respect to theta. What's the antiderivative of a derivative? Well, there's a lot of ways that you can approach this integral. The integral of dy, it's just y, plus a constant. Right-hand side, that's going to take more work. We're going to have to use power reducing formulas twice. Because I'm not going to go back because it's like 30 pages. An even sine exponent times an even cosine exponent. Here there's no cosines. We just have the even sine exponent. That's the power reducing formula's case. Because no u substitution will work here. And Pythagorean identity doesn't help us either. So remember that the sine squared of any angle is 1/2 minus 1/2 cosine. I do this every time. Cosine of double that angle. Well, this is sine squared of pi theta squared. Oh, and again, we're going to have a plus c on the right-hand side. And so a constant plus another constant doesn't matter. So we can really just drop the c for now. Make sure we add a c at the end. So this is going to be the antiderivative. What's sine squared? Reduce the power. It's 1/2 minus 1/2 cosine of double the angle. What's double this angle? 2 pi theta. Ah. Let's keep simplifying. So y is going to be the integral. Let's FOIL it out. 1/4 minus their product is 1/4, and then double the product is 1/2 minus 1/2 cosine of 2 pi theta plus the last thing squared. And we have to use the power reducing formula on this guy again. It's a little tedious. So we're going to get the antiderivative of 1/4 minus 1/2 cosine 2 pi theta plus 1/4. Use the power reducing formula, which says this is 1/2 plus 1/2 of cosine of double the angle. Double the angle is 4 pi theta. And now we can collect like terms, simplify, integrate, the whole shebang. So if we do that, integral of 1/4 minus 1/2 cosine of 2 pi theta, distribute, plus 1/8 plus 1/8 cosine of 4 pi theta. Wait, haven't we've done a very similar integral before. Not the same though. And then 1/4 plus 1/8 this time. It was minus 1/8 last time we did this because I don't know why. Was it? Did I make a mistake earlier? I don't know. Anyway, here it's plus 1/8. All right. I'm not going to worry about it. 1/4 plus 1/8 is going to be 3/8. Right. And that's the only thing we can combine. So integrate in an antiderivative of 3/8 is 3/8x. This next one, antiderivative of cosine is sine. But we're going to have to divide by 2 pi. That's 1/4 pi. And then this last thing is the same idea. Antiderivative of cosine is still sine. Divide by 4 pi now. All right. Plus constant. This is the solution. There are infinitely many solutions to this differential equation. This is one of them. Well, this is all of them, actually. And you could check your answer a couple of different ways. One of them would be to take the derivative and do all those integrals. The other would be take the derivative and the other one would be to take the derivative and graph them, or it's an odd problem. We can check our answer. 117. 3/8 theta. Oh, oops. This is the integral with respect to theta, Jason. What are you doing? Minus 1/4 pi sine of 2 pi theta. Good. Plus 1/32 pi sine of 4 pi theta. Good. Plus c. They write it equals f of x. I write y. But remember, the whole thing was find a y, which is some f of theta. We did that. Problem done. Differential equation solved. That's the easiest type of differential equation. There are many, many types of harder ones. Last problem of this video. 124. Where's my book? All right. Determine which one's more difficult to evaluate and explain your reasoning. Okay. This is kind of funny. We're not probably going to write anything down. No, let's write it down. Integral of sine to the 456 power x cosine of x dx. Or, wait, these are not equal. Or sine squared cosine squared. We've actually done the second one before. So the whole point of this is that even though this looks more complicated, it's really not. To do this red one, we have to do the power reducing formula twice. Or 3 times. Yeah, 3 times. There's a way to only do it twice. But it's a real pain in the butt. Okay? That's power reducing formula is annoying to me. Whereas this one, this is just a U sub. In fact, I know the answer to this one. It's 1 over 457 sine to the 457 x plus c. I can do this one in my head. I certainly can't do this one in my head. And that's what it wants you to recognize. It doesn't actually want you to do this in your head. But just look at them and say, well, which one of these do you want to do? Choose that one. So that's what I want you to do for 125 too. Okay? 125 is a different kind of subtlety, but the same kind of idea. Let me know if you have questions and have a great rest of your day.